All right, well, thanks very much for joining us today. This is the second session related to the RecurDyn V9R4 introduction. And so as with the first session, we'll go into a bit of detail on the new functionality. One thing I wanted to point out before we get started is I'm pulling another window in here. I just wanted to let you know that there are some resources that are part of the installation. So once you get the download link and you install RecurDyn V9R4, you'll have access to this document, the V9R4 What's New summary. And so that will, just like this presentation, it will walk through the different capabilities that have been added. So this is more in a page-by-page format versus the PowerPoint format of the webinar. And then the other thing is release notes for V9R4. So with every release, we have these release notes. The one thing in particular that I find is this is a great source of information with regards to the latest version of the different interfaces and libraries that we're supporting. So if you ever have any question about what's being supported, you know, as far as Parasolid version, whatever, that's available here in the release notes with each release. The release notes, you can see, are very short descriptions. So kind of the great thing here is the release notes are offered or put together by the development team, and the what's new is put together by the technical marketing group. So it's a different perspective on the two documents. Okay, let's go ahead and get started. You know, today, as Hannah mentioned, we're going to do MFBD and Toolkits. The first session we covered the GUI and the solver enhancements, so that's a separate webinar. Okay, MFBD. So MFBD is multi-flexible body dynamics. That's our term really for the full flex module being added into RecurDyn, which enables the nonlinear flex body. And then also the RFlex module for the modes-based flex bodies. So we'll really be covering those two modules, RFlex and FFlex, in this section. So kind of the biggest news for this release is that the full flex module now includes heat transfer capability. So we refer to that as full flex thermal. We're currently offering it with full flex at no extra charge. You know, it may be in the future that when enough capability gets added, it may become a module that we'll need to charge for, maybe with some newer capabilities, but with the capabilities here now, that's provided just as part of any FFlex license. So the FFlex thermal is looking at transient nonlinear heat transfer. And as you can see, there's some basic inputs that are being considered. So you can define things like a heat flux is defined, you know, along the surface, element faces. In the elements themselves, they have heat transfer properties, and also they have the option of defining heat generation within elements. There's nodal temperatures that will result from the heat transfer analysis. You know, some of you may remember that in previous versions, we also, we already had the ability to define nodal temperatures manually and then use that information to calculate thermal stresses. So that the nodal temperatures can now be generated by this capability, and then the thermal stresses are then generated. Oh, and the last thing is that you can define a convection boundary condition as well. And then as a result of that, you can get some kind of temperature distribution. And you know, our main interest here is looking at things that are dynamic, as always. And so here, because of the different boundary conditions, different heat flux being defined, we get this certain temperature distribution, which then can result in thermal stresses, which then can result in deformation of the part. So this is an important capability. After this session 2, general session 2 on the V9R4 release, we're going to have another webinar by James Christ, who will cover the heat transfer capability in some detail, but I'm just introducing it here. So again, more detail after my presentation on heat transfer. Okay, so with the MFBD and the FFlex, one major area of enhancement, as usual, is related to meshing. So there's a new capability in the V9R4, and if you look at the mesh dialog box as shown in the lower left, you can see there's a new field with a checkbox that's called RFlexGen Merge. So this is a real time saver. So what we can see on this slide is we can compare with V9R3. There were ways, to do the mesh merging, and why do you want to do a mesh merging and multiple meshes and so forth? Well, you may have a solid or a body that's comprised of multiple solids, and maybe those solids have kind of different geometric features such that it would be advantageous to mesh them separately to get the mesh that one desires. But you do want to then put those meshes together, combine them. So with V9R3, you had to do things like you had to imprint an edge, look at it, identify common edges between the bodies. Then you would do some surface or some meshing, and then create a patch set, imprint the patch set, and then do the meshing of the second body, and then do the merge. So with this new capability in V9R4, you simply check the RFlexGen Merge, and then you just do your first mesh, and then you do your second mesh, and things will be merged together in that body. So it's really takes a lot of tedious work out of the equation when you're doing these multiple meshes. So we do have a number of clients who have been doing this multi-meshing, and it has been quite tedious with V9R3. But with V9R4, we've done some evaluation, and not only is it faster and more efficient, it's also actually more robust. So some of the combining the merging of the meshes, were not working out very well in the past with the V9R3, but with this new capability, it works fine, and it's automatic. Some additional meshing options. As we look at, so this is an entire dialog box, and we're going to go over 2 different slides here to cover all the different capabilities. But basically, you can go into this additional mesh option dialog box. First thing on the top is optimization level, and what that's all about is actually the element quality. And so this optimization is, as it says here in the labels, controlling both the element shape and size. And to see the effect of it, if we look here to the right, if we have the optimization set to a lower level, these yellow faces that are highlighted, this is when you do the quality check on the mesh. And that will highlight, the elements, the faces that are not meeting the quality standard. So you can see with the low level of optimization, we have quite a few elements are not meeting quality standard. When we switch to a higher level, then many of these elements are now corrected to meet the quality standard. So that's just a slide bar that you can control. Second thing is this gradation factor. And so that's looking at during the meshing process, the way the mesher actually works is that it starts out with a surface mesh on the outside, and then it's actually meshing towards the center. And that really makes a lot of sense because the highest stresses tend to be on the outside of the geometry. and the lower stresses tend to be inside. So we really want to have the best quality on the outside. And for example, when you do a hex dominant mesh, it'll tend to have, pretty much 100% hex elements on the outer layer, and then as you go towards the center, then it may have to introduce some other elements here and there. But anyway, that's providing, the best results in general. So this gradation factor, it's going to control how the element size changes. So if you look to the right again, oh, and by the way, there's also this internal element size. And you can check that internal element size to make it active. So this on the left here, you can see what, that the gradation is not happening. So I assume this is gradation factor of 1. And then, on the further to the right, on this mesh, where, we do have the gradation factor with the value greater than 1, and also set the internal element size, also to a certain value. Anyway, so now we get this mesh, less elements, but as far as the results of working with this body, you can end up with less elements and still have the same accuracy in the results. And so that's, something that you want to try out and then compare results. Make sure you're not, losing any quality. I mean, if you do see a difference in the results, then maybe what you want to do is, kind of head back, towards the direction of having, kind of the starting point. But, you just need to experiment a little bit till you get the right combination where you're going to get faster simulation with less elements, but still get the accuracy. The next one here is patch angle tolerance. And this one, when you have a curved surface, and you're kind of, going around the curvature, it's gonna, basically control the angle, between these patches on this curved surface. So you can see if we set this angle down to 1%, we're getting a really dense mesh, and big differences between the patches. If we set it to 20%, then we're getting this more uniform and larger elements. So depending on your geometry, this patch angle tolerance can be something that you can use to get the mesh to have element sizing and distributions the way you would like it to be. All right, continuing down on the same dialog box. Next one is we have minimum number of edges along loops and maximum number of edges along loops. So if you look here to the right, in this case, we're saying, the minimum is number of edges is 3. And so basically, we have this loop shown in red, and it's just fitting in a single triangle element. But if we set the minimum number of edges to be 300, then we're getting, a full set of elements around that loop. So it's a matter of controlling the accuracy there when you have loops in the geometry. Next one is forcing number of edges in lines to be even. So if you have a geometry, as we see here in the middle, this half circle, so one line would be the semicircle arc there. The other line would be the straight line, and same with the bigger semicircle. So if you set things to be even, in the case of the left, the elements along the line, elements along the arc, it's both 4. In the case where that's left off, then in this case we have 6 along the line and 10 along the arc. So it's just another option you have if you want to control the element distribution, along certain curves and so forth. You may have geometry that's, some kind of rectangle, And so, you can turn this on, and then, all the elements around all four sides of that rectangle will be the same number of elements. So you may want to impose that restriction sometimes. Okay, next one is this checkbox here for triangle, triangle, and quad, quad junctions only. And so this is toggling whether or not this the internal patch that's common to two elements must have the same topology. So if you have two elements coming together, there's a common side, and this is controlling something about that topology. Last one is auto cleanup of the shell mesh. So as I mentioned earlier, when you're doing the solid meshing, the first step is to do a shell mesh on the outside. So if the solid mesh fails, it could be because the shell mesh itself wasn't really set up properly. So by checking this auto cleanup, if the solid meshing fails, then RecurDyn will get rid of that corrupt shell mesh, and then it will go and fix the shell mesh, and it'll be checking things like the free curves and the T connections, which is a good way to check for like some redundant conditions and so forth. Anyway, we'll try to fix that shell mesh, and then we'll try to redo the generation of the solid mesh using the shell mesh, and so that's another new option. Okay, another new feature is that you can now remesh any mesh in a body. The restriction in the past was that you can only remesh the latest target of meshing, and then once you meshed a new solid, then you couldn't go back to an earlier mesh. But now you pick the geometry as shown here with this GR button. You pick whatever geometry you want, and then you can do that remeshing. There's the ability to extrude manual mesh, and so now there's a new capability that you can create this new extruded mesh, and then you decide whether or not to keep the source mesh. If you are keeping the source mesh, then you can elect to merge that with the new mesh. So the new mesh gets merged with the source mesh. So this graphic here on the right shows a starting mesh, and then with different extrusions, it continues to merge everything all together. So you end up with a single mesh that has all the different extrusions in it. In this case, you can see how the meshing was done, with varying element sizes and so forth for that application. Big news for RFlexGen is that there's now a new solver available for doing, this eigensolve. So the solver that we've had in the past, its name was Dynamis. So now there's a new solver that has the name of Sunshine. So I guess this makes it easier to remember. Sunshine is like the newer one because it's a more positive name, I guess. But anyway, you can pick. So if you're in the middle of a particular project and you want to install and start using V9R4, then maybe you want to stay with the Dynamis solver just for consistency's sake. But then once you start a new project, then you can try out the Sunshine solver. And as we look here in the lower right, this gives us some kind of indication. So the first plot on the top here, it says, showing different models, different numbers of nodes, up to 100,000 nodes. And this is doing the creation of the, the eigenvalues, eigenvectors, with generating the stress and strain modes. So that's an option that you have, and you need to do that if you want to do some kind of stress recovery. So when you have that option turned on, it's actually a 3.5 times speed improvement. And the chart below is showing, creating the eigenvalues, eigenvectors without the stress strain information. And in that case, we're going up to 1 million nodes. And what we're seeing is that, I mean, at the very, you can see at the very small models, maybe you won't notice much of a difference, but it doesn't matter because it's fast. But as you get to the bigger models, it should be 1.5 times faster to use the new Sunshine solver. And then as far as, comparing the accuracy, this chart on the lower left, compares the results of the old solver, the new eigensolver, and then also comparing with NX-Nastran version 2019.2. And so we're comparing the frequencies, and as you can see, there's always going to be a little bit of a difference, but see, it's down to like 1 or 2% on the frequencies, so that's quite acceptable. And you can see the sample problem that they looked at here, and then they're just comparing, modes 7 through 20. So anyway, this new solver, we think is pretty exciting, and so just glad to see this improvement. Okay, we have this new capability related to working with beam elements, and I don't know how many of you have tried it, but with FFlex, you can like pick a curve and you can create beam elements along a curve or a straight line. So the thing of it is that in the past, when you created a collection of beam elements like that, it was assumed that the set of elements were in a, unstressed state. They were kind of at rest. And in some cases, it's really helpful to be able to start out with the beams, in their deformed state and already pre-stressed. So we can see one example. We can see one example here where we're using these beam elements to become a cable. And we have this cable acting between two rollers. So what you had to do in the past, since everything was assumed to be at rest, you would start out with a straight set of elements and then start, basically going through a manual assembly process, but doing it step by step in RecurDyn, and then at the end of each step, then doing a model extract and then apply the new change, and then finally, we show here at the right everything in its proper starting condition, pre-stressed and everything. So in this case, now with V9R4, you can define these elements along a curve, and then you can just check this box here, create beam element with pre-stress, and then it will know that that the position of rest is when all these elements are straight. And so then when they're pre-curved, then they will automatically be pre-stressed, and you don't have to do all these model extracts and everything to get to the pre-stressed state. So this can be a big time saver. And and I think to be able to use FFlex to do these cable type problems, not only interacting with rigid bodies, but also can be acting with flexible bodies, opens up a lot of interesting simulations that can be providing some really useful information. So I'm interested in knowing, people's needs or interests with regards to, having more capabilities related to, cable type problems. So if anyone is interested in that area, please contact me, and we can have a discussion. I'd like to kind of gather up, the requirements for what we might want to have in the future with regards to cable modeling. So that would be very helpful to us. Here's a capability to actually extract more information, and this is at the nodes. And so on the left, this is the default list of outputs. And then in particular, we've circled the different stress and strain information at the node. And we can see that we have a new option to output principal component of stress strain. And when you turn that option on, we can see the total list gets bigger. Why is it bigger? And basically I've made a circle here around these new entities. So you have the principal, stresses here, and that's the S1, S2, S3. But then below that, now we have the X, Y, and Z components of those principal stresses. And actually, we have the same thing with the strain. So we have the E1, E2, E3 for the principal strains, and then again, we have the same collection of additional X, Y, and Z components for those three strains. So, if you're interested in this, and if you have any difficulty, please let us know. I found information that this option is turned on under Home Setting, Flexibility, and then Flexible tab. But I actually checked on my version of V9R4 and couldn't find it. So I will be checking with Function Bay about that matter. We'll find out the answer to that. But if you're interested in this capability, please let me know. Okay, another RFlex enhancement is that, with FFlex in the last release, we added the same type of enhancement. So that was, last release was FFlex, this release is RFlex. And what the enhancement is that when you import a body, it used to try to infer the orientation by looking at, what orientation you were in. So it doesn't do that anymore. It actually just keeps track of what the original orientation was in space, and then it just makes sure it's the same in RecurDyn itself. So that's, I think this is the way it should be. The body will maintain its original orientation, and it will consistently come in that orientation no matter, what working plane you happen to have active at the moment. Okay. There's an option, or sometimes, like when you're using the G manager to switch between, rigid bodies and then RFlex bodies, FFlex bodies, to change the state of the body. Sometimes you want to be able to reassociate, and then, other times if you've made a change, you may have a modified RFI file, and so you want to reassociate the new RFlex RFI file with the particular body. So it used to be in the past, only the number of nodes were checked to see if it was valid to use this new file. But now a lot more checking is done. So it's going to check number of nodes as before, but also check number of elements, number of modes, that the number of modes are less than, number of modes and the frequencies. And so then if things are not matching with what was there before, then it will provide a message and not reassociate that RFI file. Then you can go back and fix the problem and try again. Another thing with V9R4 is that RecurDyn now supports the ANSYS binary file for RFI generation. So, that you have the option of doing the modal analysis and external finite element codes, whether NX Nastran, MSC Nastran, ANSYS, so forth. When you do that, those codes will generally output some binary format files, and then we have a library and capabilities that we can read in those files and then generate the RFI file. So now we support that latest format in ANSYS. Okay, when you're importing, a mesh, basically, if you're generating an FFlex body, there's a warning display for unsupported elements. And it used to let you know about each and every unsupported element, which was kind of tedious if you had a few thousand of elements that weren't supported and too many messages. So now it doesn't repeat the message. It's just if it sees, when it sees the first unsupported element, it puts out the message, and then when it sees more of the same element, it doesn't say anything else. And and it provides some feedback. So you get what you see here in this window. So this is much better than before, because with the huge quantity of data that would sometimes come out, it was hard to keep track of overall what happened. But this way, it's quite easy to find out which elements you have in your mesh that are supported. Next thing is there were some creation modes that were not really appropriate, so those have been removed in V9R4. So nothing really to be too concerned about, other than the fact that you won't have to look at the stuff that's not useful. There's a way to now select this flexible entity function, and this is active both with FFlex and RFlexGen, and also when you're in the mesher. But you can use this mode or this icon off the toolbar, and then you get this dialog box, and it gives you a chance to select an entity, and then when you select it, then you get the feedback about the information on it, and then you can change certain things and then actually click on the update. So that's a new tool that can be quite useful. When working with the beam elements, you can designate stress strain recovery point, and you have all these different options here. So this, these locations of C, D, E, and F, for a beam element, documentation will show you where that's at, but that's just a standard beam thing. And then another possibility is the maximum distance from the centroid of the beam. So you would want to do that one to see the highest stress, in the different directions. And then the von Mises stress will give you the total component. So that's new for V9R4. When you run a simulation and it includes a flex body, I'm sure you've seen that when you pause the simulation and maybe you want to plot or plot certain things, or just review the animation to that point or something. Anyway, if you have a flex body, generally a little alert box pops up and says, oh, I'm regenerating, or I'm generating all this information related to the flex bodies, so that things can be displayed with regards to the flex bodies in both the animation as far as the contours and in the plotting. So that's all logical and useful, but sometimes you have models where you want to stop, do the pause and then kind of check things out, but you really are not concerned about details on the flex bodies, and you don't want to wait for that generation task to occur with each and every flex body. So this is a new option here that you can skip that output generation, which also means you can't see the flex body results at that point. But again, some models you really don't need to see it at that point, and then you don't have to wait. Okay, next one is for a number of releases, we've had this ability to define a special color on the color contours to say, if you're manually setting the min and max stress that you're displaying, and then that'll go through a certain range of colors. But then what do you want to do when it exceeds the max? So, the exceed the max has been available, but now with this release, we've also added what happens when the stress is less than the minimum. And so you can, flag certain colors you know, the max color within the range, you know, is a red. So if you're to make this red, then anything above that is still going to be red, you know, if you don't want to highlight that. But sometimes you do want to highlight the max color or the min color, so then you would set it to be something very distinctive. You know, the minimum color within range is going to be blue. So in this case, we're using purple to make it distinctive. So you can control that. Okay, next one is that when you're exporting nodes, you know, you're using these exported nodes, you know, on this contour export. When you have those nodes, you have a button here where you can say, hey, I want all of these, you know, nodes that are, you know, part of this contour thing. I want all of those to be nodes that have output saved for them. So this is a way that you can create, I mean, you can go in and select the nodes that you want to have all the details output for, you know, in a general way. But then that takes, you know, there's a selection process, and we have some tools to do that, but it still takes some steps. But this way, if you already have a node set that you're planning to use on this export, then you can just directly make those output nodes with a single click of the Create Output button. So that saves a lot of time. Okay, now we're going on with toolkits. And by the way, if you have any questions, we will do questions at the end. And if you're viewing through YouTube, you'll need to be signed in to be able to submit a question. So, you know, and again, it's good to sign in so we know who you are to give you the download link for this new version. And if for whatever reason you can't sign into YouTube, then please, you know, just send us an email and let us know you were here so that we know to send you that download link. Okay, we're going to start with the gear toolkit. So there's this new capability that with gears you can basically define, you know, there's a separate, you know, notion of the web, and you can make that web flexible. And there's actually a tutorial also about doing this flexible web that's available, so you can try that out. So, you know, the purpose of adding in the flexibility is in some applications, the web, you know, has been optimized, and, you know, there's concern about just making sure that the stresses in the web are not too high. So then you can just represent it as a flexible body. And, you know, then there's, you know, as you can see, there's a variety of options. So again, the tutorial will show you all that. And then the other thing is on the gear web, you can also swap in, you know, different geometry from using a CAD geometry, and then replace what's there. And then when you have a gear web group, you know, there's now this involute gear contact set up for that. Anyway, we're adding more and more capabilities with the gears, and then of course we also have the interactions with the KISSOFT definitions of gears and bearings. So really have made a lot of progress in that area. Okay, so in this drivetrain toolkit, which, you know, does include the gears and bearings, we now have in the shaft property dialog box, there's this new start point direction and reference direction options, you know, so that you can more precisely get the shaft defined the way you would like to have it defined. We've also added support now with the Linux solver to be able to do the drivetrain capabilities, and specifically this gear meta model. And you know, the meta model is a way to pre-exercise the gear in advance of the simulation, extract out results, and then during the simulation with whatever loading conditions are going to be some combination of the cases that were looked at before. So then interpolation can be done to very quickly give answers so that you're seeing the accuracy of the Kissoft gear contact, but then it's combined with the speed of taking that accurate data, putting it into a meta model, and then using that to address the cases that occur during the simulation, because they'll be somewhere in between the cases that were done before. Chain Toolkit. This capability has been available in the past with the roller chain, with the regular sprocket, but now it's supported with the silent chain assembly that you can simply check this new entry here in the assembly dialog box for automatic sprocket alignment, and the two sprockets will be aligned with the chain so that you don't have to do that manually. So we can see the automated gear engagement that occurs with that option. For the media transport toolkits and the MTT 3D, it now supports orthotropic and isotropic material properties. So if you have certain properties along the direction of travel, and then other properties, across the width of the material, whether it's a cut sheet or a flexible belt or just flexible media, you can now input those properties so that you can see the proper behavior, and that could affect curl development, and also could affect wrinkling and a variety of things. So that's why we added in this ability to do the be able to input the correct properties and not just have isotropic only. So it should be very useful. With the MTT and the belt toolkits, for both of them, well, all of them. I mean, so all the MTT toolkits and the belt toolkits, roller toolkit, I think, everything, we now have this force display, which wasn't available before, and so you can display the contact force, and you'll see it, kind of segment by segment with respect to the belt or the different segments on the paper. So this is really awesome because you can see the distribution of the forces because it's split into the different pieces. So this makes things more similar to like the geocontact, which can also display the separate force entities. And as we talked about in the first session, as you see here in the lower right, this ability to display the force magnitude is also part of that capability, numerically. The elasto-hydrodynamic bearing has been enhanced. So you can set oil pressure boundary condition at the for the piston. You can, there's a measuring tool for piston clearance at the start time to check that. You can use a scope to display these piston profiles, and that's shown here in the lower right, the scope. And it supports, using an expression to define the rotational EHD oil hole / groove pressure values. And that's, shown here where you can choose between a value and an expression. And you can also define a cutoff for the 3D surface contour. So you may have seen that sometimes there'll be big, huge spikes coming out. So you can control that so that it's not too distracting and keeping you from seeing other aspects of the output. The standard particle interface has been enhanced to provide additional data, and then you can pick that data from the dialog box and then have the color shading reflecting whatever the quantity is. So in this case, we're selecting the translational velocity magnitude, and then we get coloration of the particles based upon that value. But you can see there's quite a list of things that can be shown. And then the other thing that's I think can be quite significant is that this external standard particle interface now has ProcessNet support. So some of these models that we're doing the co-simulation with either ParticleWorks or EDEM, you can do some of the model setup can now be automated as a ProcessNet application because of the new support for ProcessNet. Okay, for the linear analysis module, you can export the motion information for the eigenvectors basically, and they can be exported. That information can be exported to a CSV file. And example here we have 2 balls. This is kind of shown opposite of maybe what you see in a textbook, but in this case we have a block at the bottom. It has a certain motion to it, and then we have these 2 balls above it, and they have certain mass and certain springs and certain spring rates. And so when you go to look at the eigen solution for this system with RecurDyn Linear, this is 2 degrees of freedom, so therefore there's 2 natural frequencies. So then with this export capability, it will export information on those 2 natural frequencies, and basically show the translation and rotations that are occurring. So what we can see here is the translations in the X and Z direction are essentially 0, but you can now see what the Y translation is for the different modes. So that can be very useful for passing along the information for other uses. There's now the ability to find a user-defined bushing position in TrackLM. So in the past we've had this left pin, right pin position here, but you can click to use the user-defined bushing positions, and then also define this notion of a bushing width. So that just allows these models to be defined more precisely. In the area of controls and tire, in controls, we're supporting FMI simulation with FMU version 2. And what you can do now is that you can have a second control input in the control simulation. So that allows you to do more separate systems at one time. And then with regards to the version upgrades for V9R4, V9R4 now supports Simulink, so MATLAB version 2020A, on Linux, MATLAB 2012A, 2016B, 2017A, 2018B, on through 2020A. All of those are supported now on Linux. And then on NX, we've updated the Simulink MEX file for the NX software, so that's also supported. And then with the standard tire interface module, we now support the new F-Tire version 2019-4. So those are just some version enhancements. So by the way, I don't think we have any clients that were using the CH script, but in any case, for various reasons, we've decided to not support that, and rather we've replaced it with this Julia script. And so the Julia script is quite capable, and I think has some like MIT origins or something. But anyway, it's quite capable scripting language. And the Julia script is also supported on the Linux solver. So just as a sneak preview, in the future, we are going to add some support for certain things with the Python script. So I think, that's a good thing that's in the plans. And, over time, I think maybe we'll add more and more Python support. And since it's so well known, I think that's useful for people who already know it. And then with the media transport toolkits, we now have the ability to display these what are called P-edges, and those are used just to fill in a rounded corner between straight guides. Anyway, and so there's the ability to define them easily, but now we've added the capability to show them on the screen to do some checking, when you're doing the model creation. ProcessNet now supports this get element type for both FFlex and RFlexGen, so that information can be extracted. And ProcessNet now supports auto design, and we have a webinar that is available about auto design. It's a system level optimization tool, and all the different aspects of setting up that system level optimization there's now an API for ProcessNet, so you can build the model with that. Okay, well, thanks very much for your attention. Again, we'll have this webinar be available for viewing again. And at this point, we'll turn things over to James Christ, who will be talking about the new heat transfer capability in FFlex.
Thanks, Brent.